welcome to Argo CD Maintainers Talk. And as you can guess from the name, we're going to talk about using Argo CD to manage clusters that are running at edge. So we're going to share our experience about how do you install workloads and manage those workloads on small clusters that don't have a lot of connectivity. And before I start the talk, let me introduce myself. By the way, sorry for the voice. It's the third day of conference, so I lost it after speaking with lots of people. So my name is Alexander Matyushentsev. I prefer to go just by Alex M. And I'm one of the co-creators of Argo project. I've been working on Argo for like 8 or 9 years already. And my primary focus is Argo CD, so that's why I'm mostly speaking about Argo CD. And also I'm a co-founder and chief architect at a company called Akuity, where we help customers to take the maximum out of Argo CD and help them manage Kubernetes. This is the slide that marketing team asked me to add. So you might know two folks, Andrew and Christopher. They are very active in the community, not just Argo CD, and they recently published a book, and this book is available for free. Just scan the QR code and you can get an electronic copy. And this is that. Hope everyone took the screenshot. I want to talk about agenda of this talk, and I will explain what I'm going to cover. So as I mentioned, at Akuity, we help multiple customers to use Argo CD. And among just building products, we also help them to come up with solutions. And so one of our customers came to us and asked for help to figure out how would they manage clusters at edge that are running at edge locations, and they described what they want to do and explained us what use cases they want to solve, and I'm going to share all of that with you. And next we try to just use Argo CD in a very traditional way that very well covered and everyone knows how to use, and we run into some challenges. And then we come up with pretty much a solution. So not a product, but a set of decisions we had to make this experience good for them. And so I will actually, it was introduced before, but I will remind about not very popular feature called Argo CD Core, and then a set of solutions we implemented to help them manage applications, keep visibility, and also solve the problem of delivering artifacts to these clusters. And now let's talk a little bit about running Kubernetes clusters at edge. So through our journey, while working with different customers, we learned that Kubernetes actually is not running only in big, large data centers. We learned that customers use Kubernetes to manage small devices that run in edge locations like retail stores. Something is exciting happening there. Retail stores, vehicles, and planes. So this particular customer actually was managing airplanes. And I even want to share like few crazy ways to use Kubernetes we encountered. So one customer manages drones, and another customer actually manages smart collars that shock cows if they're trying to go out of range, which was like mind-blowing to me, but they are pretty happy with the experience they're getting. And so what's common about all of those use cases we noticed is, so in most of the cases, we have one team that are dealing with a lot of small clusters. And so they definitely do not treat them as pets. They treat them as a cattle. It's a very famous phrase. And so there is a lot of clusters, but each cluster is rather small, and they are dealing with low amount of resources, so not a lot of memory and CPU. And networking is the biggest problem. So clusters have connectivity, but its bandwidth is not great, and connectivity is sparse, so we need to be ready for harsh environment where workloads on the cluster cannot talk back to internet. And all of those teams pretty much doing very similar set of tasks. They want to install so-called cluster add-ons, which is a small set of applications that needs to be installed on all clusters. And so they prefer to kind of minimize amount of management they have to do. So it's not like hundreds of repositories. It's usually one Git repo that represents state of all of those clusters. And so I'm saying same set of applications, but in reality, there are different types of clusters. And so they kind of, each team has their own way of grouping, but those groups have slight differences. So simplest example, maybe they are serving different customers, and some customers more open for, they're willing to run new versions of applications, and then they get upgrades sooner than others. So there are differences between cluster groups. And all teams want to have ability to take over control over one particular cluster and experiment with it. And so some kind of dynamism, some flexibility is required. And so that was our inputs. This is what we were trying to help our customer to achieve. And our first approach was to just try to see if we can use Argo CD the way we normally use it and manage all those clusters. And on paper, it kind of sounds good because Argo CD has these multi-cluster capabilities. You can register lots of clusters and just manage them using Argo CD UI. And quickly, we realized that even when those clusters have connectivity to internet, they are never accessible from outside. And that was basically a big showstopper. So we cannot use Argo CD the typical way because it must talk to the Kubernetes API server to make any changes. And so there is another pattern of using Argo CD where you can just install it on a managed cluster itself. And so that's where we kind of redirect it. And it's totally possible, but we have some open questions. So we're losing QI, and it's unclear how administrators are going to manage applications that they're going to run on those clusters. And they did want to have ability to not only create list of applications once, they wanted to modify it with time without SSH into each and every cluster. And so they asked for this functionality. Also, we wanted to have some visibility. So the biggest request was if something goes wrong, they need to know which application and which cluster. And then there is other ways to troubleshoot it. But this high-level visibility is a big ask. And knowing Argo CD architecture, we realized that there is another problem. So Argo CD expects Git to be available all the time. And this is just not the case on the airplane. And so we needed to come up with a solution for that. And yeah, the diagram here is this is the typical way of installing Argo CD. And as you can see, it talks to many clusters. So the solution we come up with, and the first complaint about using too much resources on each cluster. And so this is actually a common complaint. Lots of hobbyists who run tiny Kubernetes clusters on Raspberry Pi and real-life use cases where you have a device with limited number of resources cannot afford to run too many components. And this diagram shows Argo CD architecture that has lots of components like API server that powers web API, web UI, CLI, and we have a DEX for authentication. And this is understandably is not required if you just have one cluster accessed only by administrator. And so to address this concern, we introduced a feature called Argo CD Core. And I guess this is maybe the primary reason for me to come up with this talk is to spread awareness about this feature. It's actually a distribution of Argo CD that do not have components that are not required in this use case. It has a set of controllers and a Redis. And what's special about Redis that a lot of people do not realize, Argo CD, to do its functions, actually do not need Redis. It's just a throwaway cache. And if you install Argo CD with user interface, we highly recommend to install high availability Redis that consists of 5 pods, 3 proxies, master and slave Redis. And if you installing Argo CD and you do not expect UI accessed by multiple users, there is no reason to have HA Redis, and it's totally safe to have just a single pod which provide caching abilities, and like high likely you will know, no one will ever notice that if Redis goes down, controller just repopulate the cache and keep working as normal, and that's why it really reduces number of memory CPU, amount of memory CPU used by Argo CD. So it's not just Argo CD core is not only distribution, it also has 2 features that let you get almost the same Argo CD experience as you get with a full installation. So you can run a CLI command that configure CLI to use Kubernetes directly. So expectation here that you have access to your kubectl, have access to the cluster you're trying to manage. And so if you run Argo CD login -- core CLI command, it will not expect API server. Instead, it will just talk directly to the Kubernetes cluster, and all CLI commands are working as expected, as normal. And you also can run Argo CD admin dashboard command, and it will, behind the scene, it just runs API server locally that serve exactly the same UI. And UI is available on port 8080 locally, and login is disabled because we just expect that this is a administrator command who kind of have full access, and it just relies on Kubernetes RBAC. So if your kubectl have access to Argo CD applications, then this UI will function, and you can just use it as normal Argo CD. And so we propose to use Argo CD core, and we kind of solved this resource problem. And so next question is how administrators are supposed to manage applications on those clusters. And solution here is, it's like I had to split it into 2 slides, so I'll move back and forth. Solution is to use application set and opinionated directory structure in your deployment repository. So this is the directory structure that I will describe shortly. I want to go back to the previous slide and just mention what is application set. I hope you heard about this feature, but the high-level description is this is a tool for administrators of Argo CD, and it's a custom Kubernetes resource that is focused on managing applications in Argo CD. And it focuses on multiple use cases. And in this particular case, as I said, we are using ability to discover directories in a Git repository and discover and do some magic matching between directories in different repositories using so-called merge and matrix generator. And this is advanced tool, so I considered explaining how exactly it works, and instead I realized that I think it's too complex to fit into a presentation, and I recommend to just go to official Argo CD documentation to learn about matrix merge generators. And I want to describe what this configuration does and describe the directory structure in GitOps repository that we come up with. So just a quick refresher about what we were trying to achieve. So the goal was to let administrator define declaratively in Git all applications that should be installed on every cluster. And then additionally, administrator should be able to create kind of overrides for a specific cluster group or even individual clusters. And then this solution satisfied the requirements of a customer because basically administrator could make all changes in Git. And so even if Kubernetes cluster at H is not available, it's fine because application set that runs on that cluster, once it gets access to Git, it will discover all the new changes and recreate, update the set of expected applications. So a few words about the structure. We propose to have this directory called cluster that has a couple subfolders, base and groups. And so base has a list of directories, and each one represents installed application on a cluster. So we had Argo CD for Argo CD itself, so it can self-manage and sample list of applications like Grafana, traffic, and so on, list of applications that are installed on the cluster. And so application set look at this base directory and create application for each subdirectory, which is its base functionality. And a little bit advanced functionality of application set is it's also able to look at the groups directory and infer the group of a cluster from a label applied to a cluster configuration. And if it notices that there is a directory for a group that matches to the cluster group, and it has a directory that matches to application that's installed on a cluster, application set will prefer this group-specific override. And this way, administrators have ability to create this QA staging or customer 1, customer 2 groups and manage settings dynamically without, connecting to every cluster one by one and updating the settings. And the cluster Snowflake use case was solved in the same manner. So we just configured application set to also match cluster name. And so if there is a folder that matches to the cluster name exactly, then it's considered the most granular configuration, and application set would prefer manifests from cluster-specific folder. So hopefully it all makes sense. And I think that was the most complex part of a whole solution. So once we did that, the next challenge was, how do we give visibility to administrators? Like, how do they know if what they deployed is even working? And the best solution that kind of satisfied everyone's requirements was Argo CD notifications and Git status. So they were using GitHub, and we proposed to just use commit status as a way to communicate back if deployment was successful or not, or if it failed. And Argo CD notifications is fairly flexible component. This YAML snippet demonstrates how you can configure notifications for GitHub. And I know GitLab is also supported, or even generic webhook. So if you're using something like Bitbucket, you could use webhook to implement the same functionality. And so every time when deployment is successful, every time when rather deployment fails or health status fails, we would send a failed status to the commit, and it's like a signal to administrator that they need to troubleshoot. And usually they would then go to the cluster that has an issue and use Argo CD core UI to troubleshoot, or just use kubectl to troubleshoot the issue. And so the final challenge was, we kind of learned it as we were going through this exercise. We realized that we were sending information about failures to GitHub. And that happened because every time cluster lose connectivity, Argo CD application controller assume that it doesn't know about the status of application because it cannot get the latest version of manifests, and it would just consider it an error. And so it was kind of undesirable behavior. And we simply solved it by introducing in-cluster Git server that we use as a cache. And we had to build a custom image that consisted of just a Git and Nginx with HTTP Git backend. And we borrowed this amazing tool called GitSync from, it's available under Kubernetes org on GitHub. And so git sync simply work as a cron job, as a sidecar, and it pull the most recent version of manifests to the local Git. And that was very simple but pretty effective solution. Once we did it, we haven't seen issues with that. And so this is kind of the high-level picture that shows the solution we come up with. We have administrator who make changes in Git repository, application set with the help of in-cluster Git server and Git sync discover those changes. When cluster became unavailable, application controller thinks that everything is normal, but once connectivity is restored, new changes get pulled into local Git server, and the changes that administrator did still apply to a cluster. And we have notification controller that sends back information about status of deployment or application health, and that helps administrator to just be notified that it's time to go troubleshoot an issue if there is any issue. And that is pretty much it. So that was a solution, and I hope you learned something new. I hope you learned about Argo CD core, and hopefully you're convinced that Argo is a suitable tool to manage small clusters and edge applications. And we have several minutes for questions. Please go ahead. Thank you.
Hi, my name's Jonathan. I work in the renewables space, and I noticed that you guys had one of the use cases up there for that. I was wondering if you have any potential customers, anyone you've worked with, who have in fact used Argo with managing renewables on the edge, and did you guys have to go through any sort of attestation for critical infrastructure protection regulations, and how did you guys manage that, if so?
I hope I heard you correctly. So the question is, did you say Google?
No, I work for NextEra Energy.
Okay, I guess, sorry, I have to ask you to repeat again. I guess I didn't hear it.
Yeah, we're a renewables development company, and we have renewable plants all throughout the US and Canada, and we'd like to go with something similar to this. The big challenge for us has been the regulations involved around critical infrastructure protection. They're very onerous regulations to test every single thing that's running on your stack. And I was wondering if you guys have any customers or ever worked with any who've gone through that attestation process, and what did you find, or how was it managed?
We had customers who require various compliances, but we had to approach it as a company. So we have our own, I don't want to use this talk to advertise ourselves. Actually, I can speak about one open source feature that we did to help customers to ensure protection. We had a customer who accidentally deleted 600 namespaces by just making it like a bad change, and they agreed it was user error, but they said it also not a good answer, because what if it happens again? And in version 3.0, Argo CD got a new feature called resource protection, and then idea was if you manage something like a namespace, it's a big deal to delete that namespace, because if it happens by accident, it deletes everything inside of this namespace. And so in 3.0 version of Argo CD, you can add an annotation to this namespace, and Argo CD, before deleting it, it will ask for a human approval either in UI or API. Literally, there is a button that says, yes, I want to delete it. And once you click approve, it's deleted. I guess that's the closest.
Great, thanks.
Thank you.
Great presentation.
Thank you.
So I'm interested, in the groups, do you create like promotion pools and ceremonies around that? So like, you specifically have your test clusters, but then beyond that, do you have like a failback to then move things out of the promoted pool for production back into some sort of test or some sort of troubleshooting cluster? How many different configurations are you doing that with, and what's the best ritual that or ceremony that you use for those clusters to actually not be just inadvertently broken because you're creating this one monolith deployment, right?
So hopefully I got the question correctly. So I guess the whole logic of this grouping is inside of application set, and what it does, it simply assume that whatever is in the base is the least specific, and then if it notices that there is a group, it's considering it as an override, and it simply updates all the applications on that cluster to use application-specific folder from the groups directory. And so, and then if it notices a directory that matches to a cluster name, it assumes that it's even more specific than group, and it switches all applications to cluster-specific manifests. And so, and there is no like pools, because all is executed in parallel on all clusters, and application set on each and every cluster continuously saying, okay, do I have an override for me? And as soon as it notices, it just updates all applications to this new version. And then each application synced to a new version simultaneously. I hope I answered.
Hi there. Thanks for the talk. We are we are in the early stage of designing a fleet management solution. And as you said in the beginning, one of the problems with the edge is intermittent connectivity. And one of the challenges that we foresee for the future is how to manage specific migration path, upgrade path for third-party application that we deliver with our application sets. For instance, let's say that we have a group and we want to promote, we have version X all over the group. We want to promote X+1. And we already tested it, that's okay. So we just upgrade the version in the group specific manifest. But then something happened, not 100% of the pool that is running version X can be upgraded. And then another X+2 comes out, and for any reason that third-party software requires going through X+1 because before going to X+2. My question is, did you face the same problem somewhere? Do you have advices how to tackle this? And
yeah, I mean, full disclosure, we finished this solution, handed over to customer, and I'm sure they did face. And so we did not work with them to solve that problem. And then I can only think loud how would I approach it. And I guess I would maybe bet on Argo CD notifications, and then instead of just sending commit status update, maybe I would have my own service that tracks status of this upgrade, and then use webhook to send updates. And I guess my goal would be to ensure that all my group was updated to version 1, and then if I need to get to the version 3, I would have this self-made orchestrator. And unfortunately, I think there is definitely, I never heard of a solution, a product for Argo CD that approaches
you basically suggest to improve the feedback loop and use it to monitor the percentage of the instances that already upgraded before going on. That's basically what we were thinking about.
That's right, yeah.
Thank you.
Okay, sorry, I will, you're going to be.
Okay. Hi, good afternoon. Yeah, it seems like you did a pretty fantastic amount of work to get this all working. Great presentation, by the way.
Thank you.
I just wanted to ask, would you actually, if you were designing a system from scratch, like the edge deployments and stuff, would you actually recommend doing this, or is this kind of something you created just to do it,
I think it was, I guess answer is yes and no. Argo CD was created with the application developers use case in mind, and we were not building it for managing, for bootstrapping clusters. And then after a while, we realized that, we want to cover this use case as well, and that's how Argo Core was created. And then while helping customers, I think we found that it's perfectly suitable for a job, and it's still a solution. So, and our customer wanted to use Argo CD because they used it everywhere else. and I guess that was main criteria. So they use it for managing applications, and the second use case was managing edge clusters, and they didn't want to have two tools. And so for them, Argo CD was
Okay, yeah, I guess I was just trying to ask, like, if you didn't already have like that kind of dependency on Argo CD, like, would you recommend this as like the solution for this?
I mean, as maintainer of Argo CD, I would be like
all right.
happy
You don't have to answer that. It's okay.
I guess, yeah, what I'm trying to say is I would work on adding, I feel like Argo CD is a perfect block, foundation to do it. It's missing first-class features for like edge management, and I would add those features. All right. Thank you. I think we have time for like one more question because we're already running out of time. We'll be kicked out soon.
So I actually work for an edge company, so we deploy a lot of these edge clusters, right? So we build our own orchestration kind of stuff. But looking at your architecture, right, I have a couple of questions, right? One is your application controllers seems to be one. How many controllers are there? Because you're talking about like 10,000 clusters you're managing. Can your controller actually manage all these application deployments without kind of performance impact, right?
In this case, so I hope I'm answering the question, please correct me. So we had these 3 different controllers running in each and every cluster, and we really did not see any performance issues because each cluster was tiny. It had like 15 applications, and it maybe was like 1,000 resources, which is it required maybe couple hundred megabytes of memory total, and that's why we did not face any performance issues.
Probably it's not really deployed in field because we see like if they deploy even 10 Git repos and they're like 10,000 clusters, now we're talking about 100,000 applications trying to go down to the downstream. We saw the bottlenecks if you use a single controllers. I'm not talking about Argo, but I've used other things like Fleet. They have the same architecture, similar architecture, and they also have the single controllers. So that's a big problem we have seen. I'm just letting you know it. That's one. Second question is, when this is happening, say that your downstream clusters are not available, right? They're all down. So where do you cache all this data? What happens at that time?
Yeah, I wanted to go back to first question. I think I wanted to acknowledge that Argo CD has, like, we heard a lot from people who run self-hosted GitHub that Argo CD overwhelms GitHub. I guess it's very sensitive to GitLS remote calls. And what was happening, GitHub would just go down, and it needed like 15 minutes to kind of cool down, and it affects the whole company. And we did improve Argo CD to handle it a little better. We introduced a less remote limit, and so this way, a customer who has lots of clusters and they don't really care about, detecting new changes next second as soon as it's committed, they would set this limit to something very low. And so Argo CD would call GitLS remote instead of multiple times a second. It would make this call once, like every minute. And then that would introduce delay, but no one cares because, if a software updated a few minutes later on this remote cluster, then so that was, it was not the case that I was describing, but we had another customer who had to deal with it, and we for them, we introduced this feature. And sorry, can you repeat the second question, please? No,
it's okay. Say if all the clusters are down, like 10,000 of them, and you're processing this application set at the top level, right? So do you cache them? Like, do you wait for the clusters to come up to pick them up? Or like, how do you cache that application set before pushing to the cluster?
So application set, I guess that was in cluster Git server. So we simply run this Git server, and it has local copy. And application set talks to repo server directly to in cluster repo server. And I want to mention that in version 3.0, we kind of improved application set performance a lot. It used to talk to Git directly without using Git repo server component of Argo CD. And that was very inefficient because it was, it didn't use any kind of caching in 3.0, the request goes to repo server and it uses cloned repo, and I know for the fact that the application set is now pretty efficient when it gets, to dealing with querying
Thank you.
Git information. Thank you. Okay. No one is kicking us out, so that's fine.
I guess my question is related to edge deployments where you're air-gapped, and if the application sets or if there's features that allow for different Git repo URLs to allow for you to do a transition where you are connected to, say, GitHub or your GitLab, and then you want to transition to an air-gapped environment, say something with like Hauler or something like that. Is that a definition you provide in the application sets, and you enumerate those in different ways? And does the local Git that's getting mirrored, I guess, collate all that into one repo, and how is that identified?
So we literally had just one repo per cluster, and in the applications that we were generating, we were just using local Git URL. So there were no transition between.
So if you have multiple GitHub or Git repos that are getting pulled down, they all go to a local one, and then all of your OCI repositories, all your Git.
Yeah, we would have to. If there were multiple repos, we would have to all sync them all onto this local Git and use local URLs in that solution to access.
Okay, great. Thanks.